Hi viewers, see we discussed kinematics. So in this chapter up to now we discussed rest, motion, both are relative, distance, displacement, speed, velocity, uniform velocity, uniform velocity, then instantaneous velocity, instantaneous velocity, average velocity. So next, acceleration. So like that we discuss these topics. So kinematic equations. Then I discussed kinematic equations. Kinematic equations. So that is v equal to u plus at is equal to ut plus of 80 square v square minus u square equal to 2as and the second displacement u plus a half and minus of. These are four kinematic equations. So we can apply these equations where uniform acceleration or constant accelerated bodies only we can apply these four kinematic equations. So based on this we discussed freely falling body, next body projected vertically up, vertically up, body projected vertically up. So these things up to now, these concepts I discussed. So now I'm going to discuss these relevant topic only. So that is body projected vertically up, body projected vertically up. So here we discuss, so this is the body, we are projecting with u not equal to 0. We projected the body with u not equal to 0. After reaching maximum height, the final velocity of the body is 0. So acceleration equal to minus z. So my question is, see the body starts with non-zero velocity. After reaching maximum height, it comes back to the ground. So what happens up to reaching maximum height? This is time of ascent. Then from the maximum height to reach the ground. So this is time of descent. Time of up and time of ascent, time of descent. The total time of flight equal to Ta plus Td, that is equal to 2E by c. So already we discussed these things. My question is, if the body starts with u not equal to 0, if the body starts with u not equal to 0, what is the velocity after reaching the ground, before reaching the ground? This is my question. So what is the question is, if we project one body with u not equal to 0 with some velocity, so what is the velocity after going reaching maximum height and comes back to the ground? Before reaching the ground, before touching the ground, what is the velocity of the body? What is the velocity of the body? So can you guess? For example, if we project 20 meter per second with this velocity, if this velocity, if we project the body after reaching maximum height, then final velocity of the body is 0, then comes back to the same projection point, same projection point. If we reach the same projection point, what is the velocity here? This is the question. So this much variation will not be there, it will comes back to like this, just here only it will reach same at the projection point only, it will comes back to projected point. So what is the velocity? It starts with 20 meter per second. What is the velocity here? So for this, just we want to calculate that one. So like that, if we project with some velocity, so this is the situation. Velocity of the body, velocity of the body on reaching the point of projection, the point of projection. So what is that? V striking, velocity of the body on reaching the point of projection. That means we started here, it goes up, then strike on the ground. So it is u not equal to 0. What is the velocity on strike the ground before reaching the point of projection? So what is the velocity for that one? So see, we can use v equal to u plus at, v equal to u plus at. So what happens here? The body goes up on reaching the maximum height, then comes back to projection, point of projection. So what happens here? This is TA, time of ascent. This is TD, time of descent. So it is going up and comes back to same point of projection. So total time of flight will be T equal to TA plus TD, that is equal to 2U by G. So here time of flight, total time, that is equal to 2U by G. A equal to minus G, you take U equal to U is not equal to 0. So just substitute these things, you can get. See what is the velocity? If we projected with non-zero initial velocity, that is u not equal to 0. So it is going maximum height. After reaching maximum height, it comes back to same point of projection. So time of flight equal to 2u by g. Acceleration is equal to a equal to minus g. Just substitute these things in that equation. So v equal to v is striking the ground. The velocity of the striking ground, u is u minus z 2u by g. See here we are taking this time is equal to time of flight. So here g cancel, you will get minus u. V striking. See from this equation what you can say? From this equation what you can say? See we got V strike striking ground equal to minus u. From this, what you can say? So the body when we projected with initial velocity u, after reaching maximum height, the final velocity of the body in ascending, the final velocity of the body is 0. Then the body comes to ground and reaches point of projection. At point of projection, what is the velocity? So the point of projection, velocity at striking point is equal to minus u. That means how much velocity we projected, then comes back to the same point with the same velocity. It's same velocity, but direction is opposite to the initial direction. Initially we projected with velocity u. So before here is striking point. After reaching ground, the velocity is same but in opposite direction. So negative means opposite direction. V striking velocity is nothing but u only. U, what is u here? Initial velocity. So for example, if 20 meter per second, if we projected the body after reaching the ground, after reaching the point of projection, the velocity will be 20 meter per second only, but the direction will be downward direction. We projected with upward direction velocity here before striking the ground, that is velocity is in opposite direction to initial velocity. So this is the situation. Just you write v strike equal to minus u. That means v strike, here you can write v striking direction is opposite to u. That's it. If you copy, just message me. If you copy, just message me. Okay, right. So this is velocity of the body on reaching the point of projection we got, that is v strike velocity equal to minus u. This is one point regarding to body projected vertically up. So one more. So in this part only I discussed one more concept. Vertical, this is also important. Vertical projection of an object, from a tower, So just read the heading. What is there here? Vertically projection of a body from a tower. For example, the height tower is this much. Then from that, just project the body vertically up. So vertical projection of an object from a tower. For example, this is it visible? This is the tower. So the tower height, let it be h. The tower height will be h. So if we projected vertically up, so here we stand here, then project one body with velocity u. If we project, it will go up and reaching the ground. So this is the path of the motion of the body when we projected from a tower which has height h. The tower height is h. From that position we projected a body vertically up. Then if we project it vertically up, it goes to maximum height point, then comes to ground. So this is the foot of tower. This is foot of tower. This is maximum height of tower, maximum height of tower. So this is the height of tower, maximum height, this is foot of tower. So when we projected maximum height of from maximum height of a tower, then reached the foot of the tower. This is the direction of path of the body when we projected vertically from a tower which has tower height h. So just so what? Okay. In this situation, height of tower we need to find height of tower. So in this situation, vertical projection of an object from a tower. Regarding to this topic, we have to calculate the formula for height of tower. So what is the formula for height of the tower? Height of the tower is equal to h. So here the displacement of the body when we projected vertical left from a tower. So up to this is the maximum point. Here it will go up plus x. Then it will comes back to the same position. This is also minus x displacement in this direction. Here it goes up maximum height, then reach this position. Then this will be height of the tower. Is it or not? Yes. See, displacement is a vector quantity, that's why this is positive, it is going up. If it is positive, just it is comes back to the same position. So this is negative. Okay. So here for example, this is take as origin. So this will become minus h. See, this is positive, this is negative. In this direction all negative. For example, this is a positive direction, the negative direction. Up to here it is okay, over. Then this is a take as a reference point. This is comes back. So this is below the origin. So that will become minus h. So total the displacement of the body, total net displacement of the body, net displacement is equal to, so this is plus x, this is minus x, then minus h. So minus h, net displacement equal to minus h. So total time of travel, that means the body starts journey here, then it goes maximum height, then comes back to the reach to foot of the tower. How much time taken? Overall traveling, that is equal to, let it is t. It is t. So just you write first these concepts, I will explain later. Just draw this picture, then write this concept. So this is a tower which has height is capital H. Then we projected vertically projection. So we projected body vertically up, then goes to maximum height, then comes back to foot of the tower. So this is the displacement covered by the body in this direction is plus x, then comes back to at maximum height point, tower of point, that is equal to, in this is opposite direction displacement, but that's why this plus x takes it is minus x. So below origin, if it is a reference point, this is a reference point, the height of the tower will here become it is minus h. This foot of the, just copy it. After copying, just message me, I copy it. Then I will explain next. Okay. Now, so for this situation, we are going to calculate height of the tower. Okay. Already you copied the picture. So initial velocity we projected with the u. Initial velocity projected with u. Net displacement, that is s equal to minus h. total time taken t, total time taken the body, the total journey, how much time taken the body. See that if vertical projected up from here to here, then comes to foot of the tower, so how much time taken, that is equal to t. Then acceleration, in this acceleration equal to minus c. Okay, these are the parameters. See, initial velocity u, displacement minus h, total time equal to a equal to minus c. So we have the equation. So body starts with initial velocity, it taken time t to reach the foot of the tower, the total displacement of the body. For that equation we have second kinematic equation, is equal to ut plus of g at square. Just substitute these values in this. S equal to minus h, net displacement only this one only. See, it goes up, it goes up and comes back to same position, so net displacement will be, here it is 0, so only it covered. See, this is the actual path of the body, actual traveling path. So up to here net displacement is 0. For example, it goes 5 meter up, then comes back 5 meter down, then net displacement is 5 minus 5, net equal to net displacement is 0. Only we got this is the displacement, that is equal to minus h. So minus h equal to, so we projected the body with the initial velocity u, time taken is t, plus here half into a equal to minus g into t square. Is it okay? Next, minus h equal to ut minus half gt square, ut minus half gt square. This is the equation for calculating height of the tower, So what is the situation actually, what is the case we considered in this topic? Vertical projection of an object from a tower, we projected vertical up, it goes to maximum height. After reaching maximum height, it comes back to the foot of the tower, it reaches foot of the tower. So for that case we are calculating what is the height of the tower. For that one, so we got the equation minus h equal to ut minus half gt square. So if we remove h, just multiply with minus all the equation, so minus ut plus half gt square. So this formula we can use to calculate height of the tower. When we use this equation, when we projected a body vertical up from a tower, ఒక టవర్ నుండి మనం ఒక బాడీని వర్టికల్గా ప్రొజెక్ట్ చేసినప్పుడు హైట్ ఆఫ్ ద టవర్ కనుక్కోవడానికి this is the equation. Here this is the initial velocity, this is the time to total journey, this is the gravitational acceleration. Just copy it first, copy it. Okay, next, so from this equation, so we have this equation, h equal to height of the tower equal to minus ut plus half gt square. Just multiply with this equation into 2, 2h minus 2ut plus gt square. So gt square minus 2ut minus 2h equal to 0. So just I changed the equation, that equation. So here just compare with ax square plus bx plus c equal to 0. Is it or not? Yes. So just compare with the quadratic equation. So here x, in the x place we have t square. So the quadratic equation in terms of t. So what are the roots for this equation? So x equal to, for this ax square bx plus c equal quadratic equation. For the x equal to, we can write minus b plus or minus b square minus 4ac by 2a. We can write. Is it or not? Yes. So from that one, just as substituted here, I am comparing with this quadratic equation. A equal to z, x equal to t, b equal to minus 2u, c equal to minus 2h, equal to minus 2h. Just I have substituted here. T equal to, is it visible? Yes. Minus b is equal to 2u plus or minus b square 2u whole square minus 4ac, 4 into a into g, c is minus 2h, multiply, you will get 8h by 2a. So here 2u plus or minus, here it will come 4u square. So take 4 common here 2 will be there, 2 will comes back, 2 gets cancelled. Finally you will get u plus or minus u square plus 2gh by g. This is the time of travel. This we can use for time of travel. So what is the case? What is the formula? This formula we can use in which case? When we projected a body from a top of tower vertically up, then we can use this formula, time of travel. So how much time taken to here to here? Here the maximum height of the tower to foot of the tower. The total time taken by the body. Just you write this one. Just copy it fast. Okay. Okay, now the wing. Now, see, in kinematics, I discussed up to now freely falling body. Conditions are initial velocity is 0, a equal to plus z. Just you remember these things, important points. Then body projected vertically up. So here final velocity 0 at maximum height, a equal to minus. This is second case. So now I discussed vertically projected from a top of tower. So in this case, a equal to minus z you should take. Then net displacement equal to minus h. A equal to minus, okay, this much only, these conditions. So I discussed freely falling body. What are the conditions? U equal 0, a equal plus z. Body projected vertical up final velocity is 0 at maximum height, a equal to minus z. Vertically projected from a top of tower, a equal to minus z, s equal to net displacement, s equal to minus h. So based on this, I will discuss some problems now. Okay. Write this problem. A body falls freely from top of tower. It covers 36 percentage of total height in the last second. Before striking the ground level. The height of the tower, g equal to take 10 meter per second square. So this is the question. Just read the question first. A body falls freely from top of tower. It covers 36% of total height in the last second before striking the ground level. The height of the tower is. So how do we calculate? Here? For solution for this, see, body falls freely from top of tower. For example, this is a tower. Body falls means u equal to 0. It is coming down. Okay. So height of the tower, let it is h. Height of tower, let it be h. So the body falls freely, that means u equal to 0. So freely falling body, I already just now only I discussed the conditions u equal to 0, a equal to plus z. So 36% of height, 36% of total height. Let total height is capital H. Total height is, let it be capital H. So 36% of H covered in the last second. That means, for example, t seconds taken, the body t seconds time taken by the body which is freely fallen, then reach the ground. So how much time taken? T. It starts here and reach this point. So for example, t seconds taken, not t seconds take is 5 seconds, for example. In last 5th second, so t is the first second there, traveling distance, second, third second, fourth second, 5th second. For example, this is in 5th second. So the body taken 5. If it takes 5 seconds, last second means in 5th second, how much displacement covered by that body in 5th second. That is in, if it is the time taken is 5 seconds, the last second is 5th second. For example, it takes only t seconds. The last second is tth second. So for that, so for tth second, 36% of total height covered. Remaining total time is t, here taken only 1 second, here only 1 second, the remaining will be t minus 1 seconds. That means total time, if it is 5 seconds, it's not visible, so I am writing here, this total time is 5 seconds, here it takes only 1 second, remaining will be 4 seconds. Okay, the last second is 1 second, remaining total time is t seconds, so up to here t minus 1 seconds. So 64 percentage of remaining 36 percentage covered in last second. Total height is h, in 36% of total height covered, displacement covered in the last second of its journey. So remaining 36 in 100 minus 36, 64 percentage, 64% of height covered in t minus 1 second. Is it, did you get the point? Did you get my point? So total height is h. In total height, 36 percentage of height covered in last second only. That means if the body travel 5 seconds, in last 4 to 5, that means so last 1 second only 36% of height covered. Remaining 4 seconds it travels 64% of height. Why it is 64? Total is, if it is 100 minus 36, you will get 64% of height covered in t minus 1 second. In last 1 second, 36%. For this, you just write formula. So last second means, okay, s equal to ut plus half at square. Use this second kinematic equation. So for this, so I am writing for this one first, 64 by 100 into h equal to initial velocity, freely falling initial velocity 0 plus half g t equal to t minus 1 square. So I am writing here 64 by 100 into h equal to half g t minus 1 square. So this is equation 1. So total time taken for total height of the tower is h. How much time taken to cover the total height? For that one equation we can write h equal to half gt square. Is it or not? Can you use like that? Is it visible first? Just you write this. I'm rubbing this one. Okay. So I got 64 by 100 into h half g t minus 1 square. This is equation 1. In time, total time t, how much displacement covered by that body? H. So h equal to half gt square. This is the second equation. Just you equation 1 by equation 2. So 64 by 100 into h by h equal to half g t minus 1 whole square by half gt square. Just HH will cancel, half G cancel. What you will get? I am writing here 232, 250, 216, 225. 16 by 25 equal to t minus 1 whole square by t square. Is it or not? Okay. I am writing here 16 by 25 equal to t minus 1 by t whole square. Here t t minus 1 by t equal to 4 by 5. Take under root. So cross multiply 5t minus 5 equal to 4t. So 5t minus 4t equal to 5. T equal to 5 seconds. T equal to 5 seconds. Now it is okay. T equal to 5 seconds. You just write up to here. Okay. T equal 5 seconds. Then I am substituting. Now I substitute in this equation. So what information we got? We got now. See, a body fallen freely falling body. The height of the tower is h. In last second, it covered 36% of height. Remaining in t minus 1 second, 64% of height. So my question is, what is the height of the tower? For this one, by using the total time taken by the body is t, total height of the body is equal to h. So based on this, I written two equations. I solved for t, I got 5 seconds. I got t equal to 5 seconds. Now I am substituting here h equal to half into 10 into 25. So 2 5s are h equal to 125 meter. H equal to 125 meter. So h equal to 125 meter, that means the height of the tower equal to 125 meter. See, based on, see what I am discussing now, I discussed in kinematics everything: distance, displacement, velocity, kinematic equations, freely falling body, body projected up, vertically projected up. So based on that information, I am giving problems to you. So I discussed one problem to you. What is that? A body falls freely from top of tower. It covers 36% of total height. In the last second, before striking the ground level, the height of the tower is h equal to 125 meter. H equal to 125 meter. Is it okay? Did you copy? Did you copy? Yes or no? If it is yes, okay. I give one more problem to you. See, second problem. A ball projected, write the problem. A ball projected vertically, a body projected vertically upward with a speed of 50 meter per second. 50 meter per second. Then the speed of the body at half of its maximum height. Maximum height. Write the problem first. Just copy the problem. A ball projected vertically upward with a speed of 50 meter per second, then the speed of the body at half of its maximum height. That means body projected vertically up with u equal to 50 meter per second. So this is the maximum height. Okay. So my question is, at half of its maximum height, half of the maximum height, what is the velocity at this point? What is the velocity? How do we here in this case? A equal to vertical up means a equal to minus g. That is g equal to take 10 meter per second square. Come on, do it. Start doing. So we can use simple equation v equal to u plus at. Can we use this? So s equal to ut plus half at square. At square v square minus u square equal to 2as, which is good suitable. This which equation is suitable for this one? So in this two equation time is there, we don't have time here, so use this equation. Third equation is very suitable here. V square minus u square equal to 2as. So v at h by 2 half maximum square equal to u is 50 meter square, 2 into minus 10, a is nothing but g, a equal to minus g, that is equal to minus 10, h equal to h maximum height by 2. Okay, so vh by 2 maximum height 2500 equal to minus 25 into h max. So we got this equation. Do you know h max actually? H max of the maximum height when we projected vertical up, the body will acquire how much height, it will go to become its final velocity will be 0. That means when we projected a body vertically up, after reaching maximum height, the final velocity will be 0. Based on this, we have one formula at maximum height, that is h maximum equal to u square by 2g. Already I discussed this one. So u equal to 50 into 50 by 2 into 10, 5 is 25, 125 meter, 125 meter. So based on that one, see, we calculated here h maximum in vertically projected upward. In that situation, maximum height is 125 meter. So we projected with initial velocity 50 meter per second, that is equal to 125 meter. So here just we substitute 125 meter, we will get the answer. Is it clear? Just copy it. So first you write maximum height. This is maximum height, in this case 125 meter. Then go for second. V square is equal to as. Here it's s equal to h maximum by 2. Okay. For this one, so we use velocity at h maximum by 2 square minus 2500 minus 25 into 125. So how much will get? Half 80 square, 125 into 25, 25 5 is 125, 25 2 is 50, 62, 31 minus half into g t square h by 2, h maximum by 2. So just substitute here, minus 1 by 2 into 10 into 125 by 2. So we'll get 5 so we'll get 125 into 5, 125 into 5 by 2. So 125 into 5, 625 by 2, 625 by 2. 60, 12, 20, 12, 50 you will get. So what is the problem is here of 2as, so sorry, 2as minus 2 into g into h maximum by 2 minus 2, 2 will get 2 maximum by 2. So I substitute here 2as. Instead of that one I substitute half as, so minus 2 into 2 gets cancelled, minus 10 into h maximum 125 will get minus 12, 50. Velocity at h maximum by 2 square equal 2500. So velocity at half of the maximum equal to plus 2500 minus 1250. So that is equal to how much you will get? 13, 2500 minus 1250, 1250. So bh by 2 square equal to, so just to square it you will get bh by 2 equal to under root of 1250. This is meter per second. This is for meter per second. So what we did, v square minus u square equal to 2as. Instead of 2as I used half here, that is a mistake. So just correct it. Minus 2 into a, 2a h maximum by 2, 2 into half cancel, g equal to substitute 10, h maximum by 2, h maximum 125, 1250 here minus 2500, it will go 1250, 1252 you will get 33, 32 something meter per second. So this is the question. If you are not understanding the solution, just you message me where you are not getting the point. So instead of here half, I correct, you just correct it. It is not half, it is minus 2. 2as I substituted here 1 by 2. That is the mistake. Is it okay for you? Okay. This is today's lecture. I discussed vertically projected body upwardly. So thank you. If it is good, message me good, then I will close the session. Just message me good or bad. First. Fast. Okay. Okay, bye.